Alright, so let's start learning. Today what we're going to do is cover a few different sections. Let's start with section R2, which is called Real Numbers and Their Properties. Now, a lot of this material that we're going to go over, at least in the first couple of classes, this will all be familiar to you from your previous math class, the prerequisite for this one. But I'll go over it anyway, and if you need any help, just let me know. Also, there is supplemental material available. If you go to the supplemental material page, there's a review guide. All of the R sections has a review packet material that you could go through if you feel like you need extra help. In general, we have numbers. Any number that you could think of. I mean, we have like 2, we have -3, 1/5, the square root of -1, pi. All numbers that you could come up with fit into 2 categories. We have numbers that are called real numbers, and we use an R to represent the group of real numbers. And we have what are called imaginary numbers that we use an I to represent. Now, if we were to combine these two, a real number and an imaginary number, that's called a complex number. But we're going to be learning about those later on in the course. But for right now, let's just talk about these individually. An imaginary number, by definition, is what we get when we take the square root of -1. So anytime you're asked to take the square root of a negative number, that's called an imaginary number, and we'll see examples later on in the course. A real number is any other number, so that would be like 1, or -3/5, or 0, or pi. Any other number that we're not taking the square root of a negative with is called a real number. Real numbers could be broken down into what are called rational numbers and irrational numbers. Now, when we have a rational number, we use Q to represent those because R is already taken with the real numbers. And for irrational numbers, some books don't use any letter, but I have seen capital I used. So the difference between a rational number and an irrational number. Rational numbers terminate. Terminate means that they end. So if you were to type it on a calculator, say you typed in 1/5. 1/5 ends. That's just 0.2. Or there's some kind of pattern. So they repeat. So that would be like 1/3 or 0.3 repeating. So if you type something into your calculator and you get a number that stops, that's called terminate. It's a rational number. And if it looks like a pattern that's continuing forever, that's called a rational number. It repeats. So an irrational number doesn't terminate. And it doesn't repeat. Generally, an irrational number you would get if you had like the square root of 2. That would be an irrational number. Any imperfect radical is an irrational number. Also something like pi. If you were to type that into your calculator, there's no pattern, it doesn't end. Now it might end on your calculator, but that's because your screen can only hold so many characters, so many numbers, but in real life it doesn't end. I think some people use 22/7 as an approximation. 22/7 is an example of a rational number, but that's not actually what pi is. It's just like close. You might even see e later on in the course, but these are all examples of irrational numbers. So like 1.25714, whatever. I'm sure you get the idea. Now, further getting more specific, we have what are called integers. Integer we use a z for because I is already taken, right? So we're running out of letters. What an integer is it's a number without a decimal or a fraction. So I'm just going to say no decimal or a fraction. So an integer, for example, could be like -5, or -2, or 0, or 13, or 7100. Those are all examples of integers. A whole number, we use W to represent, and a whole number just represents 0 and positive integers. So 0 and the positive integers, 1, 2, 3, 51, 1 million. You guys get the idea. What a natural number is, a natural number would be just the positive integers. So that would be like, not 0, 0 is a whole number, but 1, 2, 3, 7, 13, 100, and so on. Right? No decimals or fractions. So you can see that we start off with very general definitions of numbers, and we get more specific as we go down this chart. So what I'm going to do is I'm going to ask you, as an example, to classify numbers belonging to a set. And the set would be -2, -1/3, square root of 2, square root of -2, and 0. We use those curly brackets to represent a set. Just kind of as a side note, anytime I see a curly bracket, I always think of a face. Like there's the eye, here's the nose, and a mouth. All right, but that's not part of the course. You won't be tested on that. It's just kind of something funny I go over with my high school kids. All right, so let's classify these numbers. And remember, we have just regular numbers. We have real numbers. We have imaginary numbers, rational, irrational, integer, whole, and natural. So let's take a look at these. First number is -2. So -2 is a real number. It's not imaginary. It's a rational number because it terminates. It is an integer, but it's not a whole or a natural number because those are only positive numbers and a whole includes 0. -1/3 is a real number. It is rational because it repeats, and it's not an integer and therefore not a whole or a natural because it is a fraction. One thing is, if something is automatically a natural number, it's also everything above it. So that's kind of how that works. So even if you have an integer is definitely everything above it. You could have an integer that's a whole number, but it's automatically everything above it. Let's go to square root of 2. Square root of 2 is a real number, but if you were to type it into your calculator, it would just be a bunch of nonsense. There's no pattern, so that would be an irrational number, and it's not an integer or anything like that. And we have the square root of -2. You can't take the square root of a negative number, so that's definitely imaginary, and it's nothing else. 0. So the most restrictive classification for 0 is a whole number, and therefore it's automatically everything else. So I hope that clarifies things. Next topic I wanted to talk about is called order of operations. And with order of operations, generally people remember the acronym, please excuse my dear Aunt Sally. So when we're simplifying expressions, we go this way. When we solve an equation, we go this way. The difference between an expression and an equation is an equation has an equal sign. So that's the difference. But what we're going to be doing is we're going to be simplifying expressions. One other thing that some people aren't taught is when you simplify expressions, between multiplication and division, you do whatever comes first, from left to right. Same thing with addition and subtraction. If you have an option of like having an addition and a subtraction in the same expression, you do whatever comes first from left to right. So with my tablet, I have this cool ability to copy and paste this. So it saves me a little bit of writing, but that's beauty of technology here. All right, so let's take a look at some examples, and I'm sure you'll be fine with this. The directions are going to be to simplify. Let's say negative 2 to the second. Well, that's pretty easy. When you're squaring negative 2, this just means negative 2 times itself. So that would be 4. So what would the difference be if I asked you to figure out negative 2 squared? Looks pretty similar to that, but really what this means is we're really doing negative 1 times 2 squared. So just be careful with that notation. And the first thing we have, we do have multiplication, but we also have exponents. So according to PEMDAS, we do the exponents first. So this would just be negative 1 times 4, which is negative 4. So you can see that there is a difference between these two expressions. What if we had something a little bit harder? Let's say 6 divided by 3 plus 2 to the third plus 5. So just follow your order of operations. We have no parentheses, but we do have an exponent. So this will be 8. Then we have multiplication and division. 6 divided by 3 is 2. 2 plus 8 is 10. So the answer for this would be 15. We have this PEMDAS, so if you're living in the United States or you're living in Japan or Europe or Australia, everyone gets the same answer. How about a problem like this? Negative 3 to the third plus negative 5 divided by 2 times negative 8 minus 5 times 3. Now, my high school students would tell me I just gassed it, which they use that as kind of like I went to a really hard problem. But let's walk through PEMDAS. First step, are there parentheses? Yes, there are parentheses, but there's nothing to simplify inside. Next step, we have our exponents. So I'm going to do that next. I'll just go step by step. So this will be negative. Negative 3 times itself 3 times would be negative 27. And then at this point, it looks like we have a lot of multiplication. Now we could do fractions, we have all this stuff. It's easy to get confused. So just go from left to right. Let's do this first. Multiply. Negative 1 times negative 27 is 27. Positive 1 times negative 5 is negative 5. 2 times negative 8 is negative 16. Negative 5 times 3 is negative 15. So sometimes people get confused with math because they try to do too much at the same time. Just break it up into smaller pieces. So now let's do the numerator. 27 minus 5 is 22. Negative 16 minus 15 is negative 31. And we can't simplify that anymore. So let's go to the next example. What if I told you to evaluate if x is equal to -2, y is equal to 5, and z is equal to -3. So I draw my z's with a line through it so they can't be confused with like a 2. All right. And what evaluate means, evaluate just means plug in numbers for letters. All right, so let's take a look. What if we had 2 times x minus 5 squared plus 4y over z plus 4? All right, so let's go ahead and plug in our numbers. So x was -2. Y was 5. And z was -3. So we're just plugging in our numbers for the letters. Now let's go through our order of operations. We'll simplify our parentheses first. So this is 2 times -7 squared plus 4 times 5 over -3 plus 4. Once we do our parentheses, we look for exponents, like right here. -7 squared would be -7 times itself. Now we do have multiplication. We'll go from left to right. 2 times 49 is 98. 4 times 5 is 20. And now we could just simplify the top, the numerator. 98 plus 20 is 118. Over 1 just gives us 118. And we'll do one more like this, where we're evaluating. Let's evaluate -2 times 3x minus 4x squared plus 3. Okay. Well, one thing we could do is we could distribute the -2, or we could just plug in our letters first, right? So let's see what x was. X was -2, so maybe we'll just plug it in. As long as you follow the rules in math, you'll always get the right answer. People run into trouble when they start making up their own rules. So, all right, so I just plugged in our numbers for our letters. I'm going to look to see what happens next. So let's do parentheses. Inside of our parentheses, we have an exponent. So this will be 3 times -2 minus 4 times -2 squared plus 3. So this is -2 times. We have a few things to multiply, so I'm just going to multiply from left to right. -6 minus 16 plus 3. Again, let's simplify the parentheses. -6 minus 16 is -22. -22 plus 3 is -19. And then -2 times -19 is 38. All right, so that takes care of how we evaluate and simplify expressions. Let's finish up this section with absolute value. Now, absolute value has a few different definitions. The most important definition of absolute value is the distance from 0 on a number line. Most people simplify that and they just say absolute value just pretty much acts as a grouping symbol, kind of like parentheses, but what's on the inside we make positive. So take a look at some examples. The directions are just going to be for us to simplify. So let's simplify the absolute value of -2. Well, here's a number line. Here's 0. -2 is less than 0. And how many units away is it? Well, it's 1, 2 units away from 0 on a number line. That's why the answer is 2. Using the second definition, make the inside positive. There you go. It's 2. And then our last example, what if we had the absolute value of 2x minus 3y if x was equal to -6 and y is equal to 10? Okay, well, let's plug those in. We'll just go step by step. 2 times -6 minus 3 times y. So doing the inside of our grouping symbols first, this would be -12. -3 times 10 is -30. So we have the absolute value of -42. -42 is 42 units away from 0 on a number line. All right, so that takes care of section R2. Stay tuned for the next lesson.